So we're going to take a look at the Pythagorean theorem, kind of what it is and how to use it. I remember that the Pythagorean theorem is used only for right triangles, at least in its base form. It has been taken and modified and manipulated using trigonometry so that it can be applied to triangles that are not just right triangles. But today we want to just basically get down the base form and how to use that before we go on to the other stuff there. And if you remember, the base form of the Pythagorean theorem is this: a squared plus b squared equals c squared. Not a very long formula, not a very complicated one. There's not a lot going on there, but it does require you to know some previous knowledge. And that is that A and B are the legs of any right triangle. So they are not the hypotenuse, which is what C is, they are the legs. The hypotenuse C is the side across the right angle in a right triangle. It is also the longest side of the right triangle. So if I put my pen or pencil on the right angle mark and I draw an arrow straight across, that arrow points to the hypotenuse. So if you're ever unsure about which side of your triangle is the hypotenuse, look for your right angle, draw an arrow straight across the diagonal, and that arrow will point you to the hypotenuse. And that is what we call C. So in this case, we don't know our C in this triangle here. And remember, C has the distinction of being the longest side of the right triangle, which is why we give it a name. And so if you're doing this problem here, there's actually a quick check you can do to see if your answer is reasonable, and we'll get to that as we get to the end of the problem. But for now, let's see how we can apply this to a right triangle like this one here. So here we have a right triangle. One of the legs is 9 centimeters long. One of the legs is 12 centimeters long. And as we said, we don't know the hypotenuse. That's unknown to us. And we want to figure out how long the hypotenuse has to be. So what we're going to do here then is we're going to plug the numbers that we know into the formula for the variables that we know. And then we're going to solve for the one that we don't know, how we use any typical equation. So in this case, the A and the B really don't matter how you organize them. I could say that 9 is A, or I could say that 9 is B. I could do the same thing for 12. As long as I know which side is C, I'm okay. So I'll go like this. 9 squared, which I'll call A. 12 I'll call B, so 12 squared is equal to my C squared, which again, I don't know yet. Now remember, this does not give me the side length automatically. This gives me the square of the side length. So it's not telling me that my hypotenuse is 10, or 5, or 15, or 20. This tells me the square of my hypotenuse, which I can then solve very easily to get my actual length. So the first thing I would do in this formula is to square my two numbers, of course. Order of operations says you do squaring before you do anything else, so I'll do squaring first. So 9 squared is 81. 12 squared is 144. Bring down the C squared. Then I'm just going to add my 81 and 144. So it'd be 225 is equal to C squared. So right now I know what the square of my answer is. I need an answer. I need the length of the hypotenuse. Right now I know the square of the length, but I don't know the actual length. Because as you see here, it says equal C squared, not equal C. Now, just like we get rid of addition by subtracting, and we can cancel multiplication with division, we can cancel squaring a number or squaring a variable by square rooting that variable or that number. So for example, if I just want C, and I have C squared here, what I can do is I can square root C squared, and because it's an equation, I have to do the same thing on both sides in order to keep the equation balanced. And what will happen is that this is just going to be C, because the square and the root end up canceling each other out. So the square and the root both go away, and I'm just left with C. And on the other side, I can either type in or just know off the top of my head that the square root of 225 is 15. So my answer would be the missing hypotenuse here is 15 centimeters long. So again, there's that last step there of having to square root the answer you get so that you actually get the full length, not the square of the length. Now, as I said before, there is a quick check you can do to see if your answer is reasonable. If you remember what I said at the beginning, the hypotenuse is always the longest side. So this number right here should be bigger than either of these other two. So if I got my answer and my answer was 10, I would know automatically that I did something wrong. Because if this side right here was 10, then that would be less than 12, but that can't happen because my hypotenuse has to be bigger than the other two sides. So there is a sort of quick check to see if your answer is reasonable. I won't tell if your answer is correct because I could have gotten, say, 16, and it would have passed that check, but still be wrong. But it is a good quick way to see if your answer is on the right track. But the formula itself is not too long to calculate. In fact, you can boil this down to just 3 steps. The first step is to square the numbers. The second step would be to add the numbers. And the third step would be to root the answer you get. And this works if you're solving for the hypotenuse. Now, the other way of using the Pythagorean theorem is solving for one of the legs of the right triangle instead of the hypotenuse. So you might be given something that looks like this instead. So if I have this right triangle here, and I want to solve for that missing side, the first thing I want to know is which piece am I missing. So remember, my formula goes a squared, b squared, c squared. And the important one is c. I need to know, do I have my c, or am I looking for my c? Well, since c is the hypotenuse, and this triangle's kind of turned a little bit, I'm going to double check and make sure my c is correct. So I'm going to put my pen on the right angle mark. I'm going to draw an arrow straight across that right angle. So 25 here is my c number. So I'm going to go to the equation. I'm going to plug in 25 squared for c, which means that these two legs here and here are both my a and my b. And it doesn't matter which one I call a. It doesn't matter which one I call b. So I'll call the 20 the a side, and this missing piece I'll call my b side. So I'm going to put in 20 for a, so it'd be 20 squared. I don't know b yet, so I'll keep it as b squared. Now, just like before, I'm going to solve this equation. If you'd like, you can draw a line down the middle of your equal sign, so that way you have everything structured. For some people, this helps make sure the work is still organized, if you're a messy writer like me. But other people don't want to use it because it's just more clutter, so it's whatever your choice is. So I want to solve for b now. I want to get b by itself. That's what we need to solve a variable for, is to get b by itself to figure out what number can I put in for b to make this true. Well, 20 squared is 400. I'll do that first. Bring down my b squared. Bring down my equals. Then I'm going to do 25 squared, which is 625. Now, last time what I did was I added my two numbers after I squared them. But in this case, I'm missing one of my legs. Last time I was missing the hypotenuse. This time I'm missing one of the legs. So if I want to solve for b, what I have to do is I have to move this 400 over to the other side. Well, how do I move a positive 400 to the other side? How do I move it away from a b? Well, it's a positive 400, so I'm going to subtract it from both sides. That will cancel this out, and I'll get a b squared. And over here, I'll get 225. And so what then I'll do is I'll square root 225, because just like before, I want to figure out what is b. So I'm going to square root 225, and I'm going to square root b squared. And that will get me b is equal to 15 inches, which is what my missing side length would then be. Not to be a pun or anything. So again, we can do my quick check here. My hypotenuse should always be the longest side. My b value is 15. That is definitely less than 25, so everything is good there. Okay, my hypotenuse is still the biggest side. If I had a b value of 30, then we'd have a problem, because now I have one of my legs being bigger than the hypotenuse. So I have to go back and check my work. Or if you forgot to square your answer, or forgot to square root your answer, sorry, and you left your answer as 225, that would also be a red flag. Because if your b length was 225, that's going to be bigger than your hypotenuse, so something went wrong there. So we can use the Pythagoreans to solve for either the legs or the hypotenuse of a right triangle, either one. And there's only one slight difference when doing each one. If I go back to the first one here, in this setup, what we did was we squared our numbers, we add them together, and then we rooted the answer, or the sum. In the second one, what we did was we squared our numbers, we subtracted them, and then we square rooted that subtraction answer. So in a sense, all the Pythagorean theorem problems can be boiled down to 3 steps. The first step is to square your numbers. I'm going to skip the second step for a second. And the third step is to root your answer. And the second step depends on whether you're finding C or if you have C, whether you're finding the hypotenuse or if you have the hypotenuse. If you're finding C, what you do is you add the numbers together. So this is if you are finding C, or if C is unknown. If C is unknown, you add your numbers. If C is known, then what you're going to do is you're going to subtract your two numbers like we did in the second problem here. And then, of course, after you add or subtract, whichever one you had to do, you're going to root your answer. So again, it's not a very long theorem. It's not a very particularly challenging theorem. The main difficulty comes in knowing which piece to use. Are you going to add or subtract? And making sure you identify your hypotenuse correctly. Because if you don't identify your hypotenuse correctly, everything else is going to fall apart. Now, one key application of this is in kind of word problems, and this actually comes up in quite a few different situations. Anything that involves a right triangle or that can be approximated by a right triangle can have some impact with the Pythagorean theorem. So let me show you one very typical word problem that comes across here. So we have a ladder. It's leaning against the house so people can go up and down to the roof. The wall of the house is 15 feet high. The base is 6 feet away from the house. How long does the ladder have to be so that the construction workers or whoever needs to get to the roof of the house can make the trip? Well, this will help if we draw a quick picture here. And you don't need to be the best artist. I'm certainly not. So we're going to draw a quick house. Here's our house. There's our roof. And it says the wall of the house is 15 feet. So I'm going to label this house here 15 feet. And it says we have a ladder leaning against it, presumably towards the roof. So I'm going to draw a ladder here that would reach the roof of the house. Okay. Now, I don't know how long the ladder is, but I know that the base of the ladder, which is this part right here, the base of the ladder is 6 feet away from the house. And unless you're told otherwise, you assume that anything that is built or fastened to the ground, like a house or a flagpole or any type of building, is built or fastened to the ground at a right angle. So we know that that right there is a right angle because that's where the house meets the ground. Now I want to know how long this ladder has to be. Now if you want to, you can take a moment and see if you can figure out how to apply the Pythagorean theorem to solve this yourself. I'll go ahead and pause here for a moment, or you can pause the video right now. So the way we solve this problem here is we focus on this little outline of a right triangle right here. If I were to kind of blow that out, what it would look like is this. 15, 6, and then a question mark right there. And then, of course, my right angle would be at the corner here. So I need to know what is that missing side. If I take a look at it real quick, that missing side turns out to be the hypotenuse of the right triangle. If I draw an arrow across, that is the hypotenuse. So because I need to find my hypotenuse, I'm going to do my 3 steps. I'm going to square my numbers, add them because my C is unknown, my hypotenuse is unknown, and then root the answer. Or I could just use the equation, which is actually a better way of doing it because it helps you get used to using equations and modeling stuff with equations. So I'm going to go ahead and do it that way. 6 squared I'll call A. 15 squared, 15 will be my B. C squared. Do some quick arithmetic. 6 squared is 36. 15 squared, which again is 15 times 15, which is 225. We've done that a lot already. And then C squared. Next step would be to add these two numbers together. I get 261. And then the last step, as with every Pythagorean problem, is to square root your answer. I'm going to draw a little arrow here so I don't go too far down. And so my answer is the square root of 261, which is 16.16 if we round it off. And this should, of course, be feet. Again, a quick check here shows that's reasonable. 16.16 is definitely bigger than 6. and it is just a smidge bigger than 15, but that's all we need is it to be bigger. It doesn't need to be massively bigger, just bigger than the two legs. So 16.16 seems to be a reasonable answer. So that is how long the ladder has to be. If you're more than that, you're definitely going to get to the roof. If you're less than that, you need to get a different ladder. And a lot of problems involving Pythagorean theorem start out like this, where there is a situation described to you. It is best to draw a diagram, because if you don't draw a diagram, you don't know which piece you're missing, whether you're missing a leg or the hypotenuse. After you get used to most of them, you can kind of picture a diagram in your head and do it that way. But when you're just starting out, it's good to kind of draw a diagram just in case you misinterpret something that's been said to you. That way you have a picture to kind of reference and back it up. So again, Pythagorean theorem, 3 steps: square. If you want to find the hypotenuse, you're going to add. If you already know the hypotenuse, you're going to subtract. And then the third step is to root that addition or subtraction answer. Hope you enjoyed the video. Have a good day.